Welcome back to next new lecture on applications of function, that is the second part of that one. In this we are going to talk about the two very important aspects of the function. One is the recursion in function, the second one is the nested function. So, first we are going to start with the recursion process. Yes, the recursion is one of the application of the functions and it is mostly, or you can say commonly used by the most of the programmers. So, what do you mean by recursion? Let us look at this one. Recursion is a process to call itself. That means a function can call by the calling statement as well as a function can call itself again. That means when the function call itself again, it is referred as recursion. It can be directly or indirectly, but here the important point is it is basically the solution for the smaller problem which can be exaggerated by calling it again into the very big problem. That means it is a very small solution for a small problem, but when we are going to call the function again and again, it will create the solution for a bigger problem. So, that means we can create the solution of a even very large one with the help of recursion process. In this the function is going to call itself again. Now, look at the example. Here we have created the function, the factorial function. The def is the definition, that means it is a function definition statement. And the next is the body of the function. Now, look at the body of the function, that when we are taking this n value from the calling statement, or you can say right now it is a parameter. This parameter is defined on two conditions. One is if number is less than or equal to 1. In this it directly return you the 1 value, because if the factorial for one number or let us say lower than 1, it directly represents the factorial value as 1. But what about if the number is greater than 1? That is included in this one, and here we can see that we are multiplying the n with the function again. That means it is a calling part inside the body. This is your calling statement and which is presented inside the body of the function. That means you can see here that on one option or on one condition the function is calling again itself, but the parameter is changed, that is n minus 1. Let us say n value is 5. Here you can see we are calling the statement in a one statement, that is fact 5. That means the number value is 5. The moment the 5 enters inside this function body, this n condition, that is 5 is less than equal to 1 is false. That means automatically it calls the second statement where it will directly calling its function again. But here the important and the most important aspect is that the function must be called with a change in its value, otherwise it will stuck in an infinite loop until and unless you get a memory error. So, here the important point is that whenever you are dealing with the recursion process, here the function must need to change its parameter constantly, otherwise it will directly go for the memory error. So, this is the very important aspect of this recursion step. Now, look at the example running in the Python window. So, here we are running this function and we are calling the factorial 5. That means the number value is 5 and you can see the output, it is 120. So, how it is going to create it? The 5 value is going to call this statement, it is 5 multiply with the factorial function of 4. Similarly, this factorial function will again call its function and there it will decode into 4 multiply with factorial. This process will follow on till the factorial value becomes 1, because at the moment the factorial value becomes 1, the answer for that one is directly 1. That means right now the process is flowing from the top to bottom, but at the ending of the factorial one, it will revert back its direction towards the original calling of the function by the user, that is factorial 5. In this way, you will get the multiply in the terms of 5 multiply with 4 multiply with 3 multiply with 2 multiply. Now you can see this represents the factorial of 5. So you will get the answer as 120. Similarly, if the number is changed 5 to 10, here you can see the factorial value is totally changed, because right now we are going for the factorial of 10, not on 5. Similarly, you can see the another example in which we are taking some return value, and the return value is in terms of the prime number. That means, let us say you put a number, let us say 10. Now you are searching from 1 to 10, or rather we can say from 2 to 10, the number of the prime numbers available in between the range from 1 to 10. So here you will get the output in the prime numbers as 2, 3, 5, 7, because these 4 numbers are only the prime which is available from the range 1 to 10. So this is a program related to this thing, and now look at this, how we are going to use the recursion function. First we are defining a function, that is we are going to check whether that number is a prime or not. The very first condition, we are limiting it, if the number is less than or equal to 1, that means we are not going to check it for prime number, because 1 is of course a number which can be divisible, which can divide all the numbers, and 1 cannot be considered as your prime number. The second thing is, if you have the number 2 or 3, because the 2 and 3 are the starting point of the numbers in prime series. So here this 2 and 3 are initial prime numbers, or you can say the initial part of the series. It can directly be fetched as a prime number, and then we are recalling the function again with the change in parameter, because if we are not going to use the change in parameter, it will directly go for the memory error. So change in the parameter is a very important step in recursion, and look at this one, that we have changed the value to n minus 1. The next thing is, we are putting this function into the res. That res is a variable, and it is a global variable with the empty list. So we are using the global and the local scope, where the res is a variable as empty list, and it is a global one. So we are appending the number of variables which are coming towards this function. The next thing is, we have created the condition. The final condition is, now if it is not 2 and 3, or if the number is not less than or equal to 1, that means this is a third condition which is summarized by the else block, and here we are again calling the function, that is n minus 1. Now look at this one, and here we have created the condition for identifying the prime number. That is, we have created a loop, and we are going from 2 to n by 2 condition, and if in between this range, if the number is divided by any value, that is, let us say the number is your 7. So we are starting with 2 to 7 by 2 plus 1, it become 4. So we are starting from 2 to 4, and in between 2 to 4 is somehow it is divisible. That means this number is not a prime number. We can directly using the break statement to get out of this loop. Otherwise, you can directly append this number inside the list, saying that it is a prime number. This side represents the main code, or you can say the driving code. So here we have started by putting the input value from the user with the help of the input function, followed by the res variable as an empty list, and at the last we are going for the display of the number. Now here we have entered the number 25. In this 25, the number of outputs as the prime numbers are 2, 3, 5, 7, 11, 30, 17, 19 and 23. So, these numbers are the prime numbers between the range of 1 to 25. 1 is not considered as a prime. So, this is another application of the recursion function, and we have completed this recursion process. So, this recursion process is a very important process in which the function call itself again. The next thing is, let us talk about little bit about this input function. Just in the previous slide we have encountered this input function. The input function is a function which provides the data from user end. You can say that means whenever the program is going to run, the input required from the user at the time of running the code, it is done by the input function. It is very similar to the variable declaration, that is, this is the variable name equal to, that is, this assigning operator followed by the data. The data will come out in the terms of the input from the user in this format. Now, look at this, the very first example. This name is a variable name, this is the assigning operator, and this is the one which is taking the input from the user. Now, here the very important point is that this input is taken from the user, and we have given them specific information that this is going to enter the username here, and this information is going to store into the name variable. That means we are directly assigning a variable name in which we are taking the output, or you can say the input, from the user. The next thing is we are going to display what is inside the name followed by what is the type of the name. Now, this is a very important question, that why we have done this thing, that we are going for the type of the variable for the input data. The next thing is, now we are interested in putting a number. That is why we have taken the number as a variable, and we are again putting the data from the user, but we want a number. The same way we are again going for what is the content inside the number after putting the data from the user end, followed by what is the type of that number. So, here you can see that we are asking the two questions, that the very first one is what is the data that is transferred to the variable. The second thing is that which type of data needs what type of instruction. Now, look at this, the very first output of the program, that we have input the data and we have given the data to the name variable, and look at this one. The data put in by the user is the Keshav Singh, and the output of the name variable is Keshav Singh, but look at the type, that is str, that is it is a string data type. Now, the next thing is, now we want a number into the number, but the output is the str data type. That means whatever you are going to ask for the user, the user will only provide one data type, that is string data type. Now, the question is then how we are going to put the number inside. Well, we need to take the help from the construction function. For the integer we need the int function. This int is the constructor function that is going to construct the data into integer data type, or you can say it will directly convert the input data type, which is the string data type, into the int. So, here this name value is going to change it into the int. Similarly, in number, if you want a float data type, that means you are going to take the help of the float constructor in order to convert the data type. So, here you are going to read this statement as we are going to take the input from the user followed by the construction function as float. Now, we then only it is going to put the data into the number. Now, look at the output of this program. Now, here we have input the number 1, 2, 3, but the constructor here is int. So, the class is int, that means this number is converted into the int value. But the second example, we are going for the float constructor, and here the value is 456, that belongs to the float data type. You know about the float data type, that whenever it includes a decimal part, it is referred as the float data type. So, you can see that the input function by default takes the string data type, but you can modify the data type into the respective data type. Now, the next one is, let us say if we want to put the data into the list data type or tuple data type. Now, again we take the help of the constructor, which are referred as list constructor for the list and the tuple for the tuple. Now, look at the output of the program. Now, little bit surprised output that we have input the number 1, 2, 3, but it has separated all the digits and put it inside the square bracket, which refers as a list by the list construct. Similarly, for the tuple, you can see that this number again degraded into the digits and it is stored inside in the round, or you can say common bracket, which represents the tuple data type. So, this is how we are going to convert into the various data types with the help of constructor. One more thing about this thing is that in the previous example of the factorial, we have just put the 5 or 10 number as a fixed number. Those numbers are not taken from the user, but now right now we can take the number from the user with the help of int function. So, here we can take the number from the user and then we can directly store it into the number and then we can directly call it into the function. So, this is one more modification of the recursion, that means the same program is updated by the user end. That means whatever data or whatever the factorial value the user wants, it directly gives that value and it in response it will get the factorial value of that number. Let us say for 7 it will the 7 factorial, the output will be the 7 factorial. So, here the output is for the 12, the output for the factorial is this number. So, we have seen that how this, whenever the data will be taken from the user and it will be taken with the help of the input function, and the input will create some more combinations with your function. So, that is how the programming increases its complexity step by step. The next important function, or you can say the application of the function, is the nested function. What do you understand by a nested term? Here you need to understand this nested term, that whenever we are going to call a function inside a function, it is referred as a nested function. Now, here you need to understand that a function need to call inside a function is referred as nested. We have come across this term so many times, like nested list, nested dictionary, nested loop, and right now the next one is the nested function. So, here we are talking about this nested function, and now look at this one. The second important point is very, very important, because in the previous lectures we have talked about the scope of the variable, and here the scope of the variable is given by the function itself. If the variable lies outside the function, it is referred as the global to that variable or function, or if that same variable lies inside the function, it is referred as the local variable. So, here we have taken the example, we have created the two function, one is the outer function, the second one is the inner function. So, we are going for the nested function, and in this we have seen that the definition of the input function is inside the definition. We are talking of the definition, let us say D is representing the definition. So, the inner function definition is represented inside the definition of outer function. You need to understand that what is right now happening is that the outer function itself is declaring everything. That means you cannot see the inner function because it becomes a part of the outer function. Now, in this we have taken n is equal to 50, that means we have created a variable n as 50, and this 50 is a local scope variable to the inner function. Why it is local to the inner function? Because it is declared inside the function, which is referred as local scope. So, this variable is totally limited to this inner function itself. That means its range is only the inner function. If somehow the inner function comes into the picture, then only you can see n is equal to 50, otherwise you cannot. The next important thing is that in the definition, this is the definition of outer function, and in outer function you can see the calling statement. Now look at this one, this is the calling statement of inner function. That means in the definition of the outer function we are seeing the calling function of the inner function. That means the only one which is going to call the inner function is the outer function. Once the outer function is called, that is the only one way we have, and that is given by the main code. The main code is we are taking a number from the user followed by the calling of the outer function. Once the function is called from the outside, it will go for the definition of the outer function. Now here you need to understand that when we are calling this function, what will happen is it is going directly to the definition of the outer function, and in definition of that outer function you can see the very first thing encountered is the print statement, that we are at the outer layer of the function, and similarly we are printing the number. This value is n, which is taken as the argument number. So whatever the number is taken from the user, it is directly transferred, or you can say we are going to check the output in the outer function. That means this n variable is right now the global to this outer function, because the definition is outside the outer function. But the next important thing is this definition part is not going to execute, because it is just like a comment statement, it will be directly skipped by the compiler. But the next step is it is calling the inner function. That means right now again the control will go back to the definition of the inner function, and in the inner function you will see that this inner function is called. And in this the very important thing is this n has 50. That means this n value, you can see this is also n and this parameter is also n. That means both are n, but the function will always give the priority, or you can say the dominancy of the locality. That means the function will always go for the local variables. It is a preference given to the function. So the n value is 50, and this n is not the global, it is local, followed by we are seeing the two outputs, that now we are at the inner level, and the second thing is we are going for the output of number. This n value is 50. Now look at the output. You can see the very beautiful output, that when we have given the 12 number, we are at the outer layer of the function. That means right now the function control is transferred to the definition of the outer layer or outer function, followed by the definition of the inner layer, which has the number value as 50. But number value 50 does not mean that it has changed the global statement, because in the definition of the inner function we already have this n is equal to 50. That means there is no change in the global. You can try it out by writing the extra statement here as the print number, then you will see that number value remains the same, that is 12. The next important thing is that was the nested function, but let us say somehow we are interested to call the inner function, but in the definition you can see that this outer function has declared the inner function inside. That means even the definition of the function is inside, but you cannot call that function directly. Why? Because the access is given to the outer function only. This means that when we are going to call the inner function directly, now this is not going to help. Why? Because you need to go for outer function. The outer function holds the definition of the inner function. Since there is no definition outside the outer function for the inner function. It will directly terminate with the error. It says that name error. Name error means such type of function is not available in our list, because it is not going to search inside the function. This is the very primary rule for the compiler, and here you can see this name error is basically indicating that this inner function is not defined. So, that means whenever you are going to call the inner function, you need to go through the outer function. So, look at this program. Here you can see that right now we have defined the inner function outside the outer function. That means we have the two function defined before the main code. So, in this main code we are calling this function, and right now we are getting the output, because this inner function definition lies outside the outer function. That means the function itself is a boundary. If somehow that function is not given the rights, you cannot access the content inside the function. Now, look at this one. Now, we are going for the global scope of the variable. In the previous lecture or in the previous example, we have gone through the local scope, and now we have defined, or we are accessing the number value for the global one. Here you can see that we are not going to change the value of n, but we are just trying to access the value of n from the inner function. So, we are just going to call the outer function, because the inner function lies inside the outside function. So, the outer function definition will directly go for the outer function, where it will go for the inner function call and then go back to the definition of the inner function. Now, here we are going to see the output, that whatever the input is given from the user, you can see as output. So, we have accessed the global variable through the inner function. Since the variable declaration is outside the function, it is treated as global, and this variable is accessed by the inner function. With this, I think so the application of the functions are totally clear. The very first application was the nested loop, in which we have talked about the function inside the function. We have some scope related problems. One is local, the second one is global, and the second one is the recursion process, in which the function is calling itself. That means the function can call itself again and again under some condition or under some changes of the parameter, until and unless you are going to change those parameters. Otherwise, you will stuck into the memory error. That means you will run out of the memory irrespective of the program length. With this, I will finish my lecture. Thank you to all.